In this video, we're going to talk about how to find the indefinite integral of logarithmic functions. Like this one. What is the integral of log base 4 of x? It turns out that there is a formula you could use. The integral of log base a of u du is equal to u times log base a u divided by e, where e is a constant, 2.7182818, that number, divided by u prime. Now, this works if, that is, if u is a linear function. So this could be like 5x, x, 3x plus 4, and so forth. If u is equal to x cubed plus 9, that's not a linear function. It's not going to work. So just keep that in mind. So in this example, we can see that u is equal to x, a is 4, and u prime, the derivative of x, is 1. So the answer is going to be u, x, log base a, or 4, of u over e, so that's going to be x over e, divided by u prime, which is 1. And so we don't need to write 1. And then plus the constant of integration. So this is the integral of log base 4 of x. So that's the simplest way to get the answer using the formula. But let's talk about how we could show our work starting from the original problem to this answer. Let's rewrite the original problem, log base 4 of x dx. So the first thing that you need to keep in mind is the change of base formula. Log base a of b is equal to log b divided by log a. And you could change the base to anything you want. So what we're going to do is change it to base e. So this is going to be log of x divided by log of 4, and then base e. Now, whenever the base of a logarithmic function is e, it's equivalent to the natural log function. So log base e of x is the same as ln x, which also has the base e, but you don't need to write e. So this becomes the integral of ln x divided by ln 4 dx. Now, ln 4 is a constant, so we could move that to the front. So now what we have is 1 over ln 4 times the integral of ln x dx. To find the indefinite integral of the natural log of x, you need to use integration by parts. So we're going to use the formula. The integral of u dv is equal to u times v minus the integral of v du. So we're going to make u equal to the natural log of x. Du is going to be the derivative of ln x, which is 1 over x times dx. dv, we're going to make it equal to dx. And so v is equal to x. So now let's use this part of the formula. So this integral here is going to equal, well, first we need to rewrite this stuff in the front, and then times uv, so that's x ln x, minus the integral of v, which is x, du, 1 over x dx. 1 over x times x is just 1. So this becomes 1 over ln 4, x ln x, minus the integral of 1 dx. The integral of 1 dx is just x. So we get 1 over ln 4, and then x ln x minus x, and then the constant of integration. Now at this point, what I'm going to do is I'm going to factor out the x variable. So this is x over ln 4, and then we have ln x minus 1 plus c. And then I'm going to distribute the 1 over ln 4 to ln x minus 1. So this is x, and then ln x over ln 4 minus 1 over ln 4. Now, 1 is equal to the natural log of e. So I'm going to replace 1 with ln e. So I have x, ln x over ln 4 minus ln e over ln 4 plus c. Now we're going to use the change of base formula to go back into our original log expression. So keep in mind that log base a of b is equal to log b over log a. And using the base e, this is going to be ln b divided by ln a. So ln b over ln a, you can convert that back to log b over log a. So ln x over ln 4 is equivalent to log base 4 of x. Ln e over ln 4 is log base 4 of e. Now, another property of logs that we need to use is this property. Log a minus log b is equal to log a divided by b. So log x minus log e, that's going to equal log x over e with the base 4. And so we get the answer that we had earlier. So it's x log base 4 x over e plus c. So that is the antiderivative of log base 4 of x. Now let's try a harder example. What about the integral of log base, let's say 5 of x plus 7 dx? Try that one. Use the formula and then show your work to get the answer. So let's start with the formula. Log base a of u du is going to be u times log base a u over e divided by u prime plus c. And this is if u is a linear function, which in this case it is. It's x plus 7. So in this example, we can see that u is x plus 7, which means u prime, the derivative of x plus 7, that's just 1. And then a is equal to 5. So using the formula, it's u x plus 7 times log base a, that's log of 5, and then u over e, so x plus 7 divided by e divided by u prime, which is 1, so no need to write that, and then plus c. So this is the answer. So what we're going to do is we're going to show the work to go from the original problem to the answer in that form. So let's begin. Feel free to do that as well. Go ahead and pause the video and try that. So just like before, we're going to use the change of base formula. So we're going to have log x plus 7 divided by log 5 dx. And making this base e, that becomes ln x plus 7 over ln 5. So I'm going to move the ln 5 to the front. So we have 1 over ln 5 times ln x plus 7 dx. So now, let's focus on integrating the natural log function using integration by parts. So the integral of u dv is going to be uv minus the integral of v du. So the integral of ln x plus 7 dx, that's going to be, let's make u equal to ln x plus 7 du. This is going to be the derivative of ln u, it's u prime over u. So it's going to be the derivative of x plus 7, which is 1, divided by x plus 7, and then times dx. dv, we're going to make that equal to dx. So v is x. So this is the u variable, and this is dv in accordance with that formula. So now u times v, that's going to be x ln x plus 7, as we could see here. And then minus the integral of v du, so that's x times du, which is 1 over x plus 7 dx. Now we need to focus on this integral. So the integral of x over x plus 7 dx. We need to use not integration by parts, but u substitution for this one. So we're going to make u equal to x plus 7. Du, the derivative of x plus 7 is 1 times dx, so du is just dx. Now we need to solve for x in this equation. Subtracting both sides by 7, we get that x is equal to u minus 7. So we're going to replace x with u minus 7, and we're going to replace x plus 7 with u, and then we're going to replace dx with du. So we have this. Now u divided by u is 1, and then we have 7 over u, and then du. So I'm going to break it up into two parts. That's the integral of 1 du minus 7 integral 1 over u du. Now the antiderivative of 1 with du in front of it, it's just going to be u. The antiderivative of 1 over u is ln u, but times 7 with a negative in front, and then plus c. Now we need to replace u with x plus 7. So it's going to become x plus 7 minus 7 ln x plus 7 plus c. So that is the integral of x over x plus 7. So what we can do is replace this part with the information here. So I'm going to distribute this negative sign to everything here. So all the signs will change. So we're going to have negative x plus 7. This sign is going to change, so it's going to become positive 7 ln x plus 7, and then plus c. So what we have here is the integral of ln x plus 7. But we want to find not only the integral of ln x plus 7, but times 1 over ln 5. So to get that answer, all we need to do is just multiply this by 1 over ln 5. So our original problem is going to equal 1 over ln 5. What I'm going to do is I'm going to divide each of these terms by ln 5. That's going to make life easier. So it's x ln x plus 7 divided by ln 5 minus x plus 7 over ln 5, and then plus 7 ln x plus 7 over ln 5 plus c. If you write c over ln 5, it's still a constant, so you could just make that whole constant c. At this point, our next step is to take the natural log expressions, convert them back into a logarithmic expression using the change of base formula. So ln x plus 7 over ln 5, that's equal to our original expression, which is log base 5 x plus 7. Now for this one, x plus 7 times 1 is x plus 7. So what we could do is just add ln e. Because ln e is equal to 1, it won't change the value. So x plus 7 times ln e is just x plus 7. So I can write this as x plus 7, and then convert ln e over ln 5 back into its logarithmic form, which will be log base, well, that's going to be just log e over 5. And then we're going to have plus 7. Converting this back into its logarithmic form, it's going to be log base 5 of x plus 7, and then plus c. Now, what do you think we need to do next? Our next step is to factor. Let's factor out that particular log expression. So if we take out log base 5 x plus 7, let me write it like this. If we factor it out, notice that we have an x and a plus 7 in front of it. So I'm going to put that in the front. So that becomes x plus 7 times log base 5 x plus 7. And then we just have this left over, minus x plus 7 log. I think I wrote that incorrectly. That should be log base 5 of e, because before we had ln e over ln 5. Using a change of base formula, that's log base 5e, not log e over 5. So I gotta correct that. I knew something looked strange with that. So that's what we should have, and then plus c. So now the next thing we're going to do is we're going to factor out x plus 7. And so we're going to have this log base 5 x plus 7 minus log base 5 of e, and then plus c. Now we could notice that we're subtracting two logs. So we can combine that into a single log by dividing these two. So this becomes x plus 7 times log base 5 of x plus 7 over e plus c. And so now we have our final answer in the form of our original formula. So this is it. So that is the integral of log base 5 x plus 7. Now let's work on the problem that was advertised. Log base 3 of 5x plus 9, and then dx. Go ahead and try this one. So let's begin with the formula. Log base a of u du is equal to u, and then times log base a u over e divided by u prime. So u in this problem is 5x plus 9. U prime, the derivative of 5x is 5. The derivative of 9 is 0. And then a is 3. So the answer is going to be u, which is 5x plus 9, times log base a, which is 3, and then 5x plus 9 divided by e over 5, which we can write that as 1 over 5, and then 5x plus 9 log base 3, 5x plus 9 over e. It looks better like that. So this is the answer for the original problem. But as always, let's make sure we can find a step-by-step process that will take us from the problem to this answer in that form. So let's go ahead and do that. So let's begin by using the change of base formula. So we have log of 5x plus 9 divided by log 3 dx, and changing it to base e, that becomes natural log. Moving this to the front, we're going to have 1 over ln 3 times the integral of ln 5x plus 9 dx. So now let's use integration by parts. The integral of u dv is going to be uv minus the integral of v du. So we have 1 over ln 3 times the integral of ln 5x plus 9. And that's going to equal 1 over ln 3. And then we're going to insert this information within those brackets. But for now, we need to define u and v. U is ln 5x plus 9. So this is u. dv is going to be dx, which for some reason I forgot to write it. V is going to be x, and then du That's the derivative of ln 5x plus 9. The derivative of the natural log of, let's say, some variable u, it's equal to u prime over u. So it's going to be the derivative of what's inside, which is 5, divided by what's inside, 5x plus 9 times dx. So now we have u times v, so that's those two. That's going to be x ln 5x plus 9 minus the integral of v du. So x times that fraction, that's going to be 5x over 5x plus 9 dx. So now let's focus on that integral. So the integral of 5x over 5x plus 9. We need to use u substitution. So we're going to make u equal to 5x plus 9. Du is going to be the derivative of that, which is 5 times dx. Solving for dx, that's going to be du divided by 5. And then I'm also going to solve for 5x in that equation by subtracting both sides by 9. So u minus 9 is equal to 5x. So now I can replace 5x with u minus 9. And then I can replace 5x plus 9 with the u variable. And then I could substitute dx with du over 5. So this becomes 1 over 5 integral u divided by u is 1, and then minus 9 over u, and then du. So this becomes 1 over 5. The antiderivative of 1 is going to be u, and then minus 9. This is 9 times 1 over u. The integral of 1 over u is ln. So this is 9 ln u, and then plus c. So now we need to replace the u variable with 5x plus 9. So it's 1 over 5, 5x plus 9, minus 9 ln 5x plus 9, and then plus c. So this information needs to go here. So right now we have 1 over ln 3, and then x ln 5x plus 9. And then we have a negative sign, so we got to distribute that. So this is going to be negative 1 over 5 times 5x plus 9. And then here we have two negatives, so it's going to be positive. We still have this 1 over 5, which needs to be distributed to that. So positive 1 over 5 times 9 ln 5x plus 9. And outside of everything, we'll just leave our constant c. Now let's divide everything by ln 3. So we're going to have x ln 5x plus 9 over ln 3, and then minus 1 over 5 times 5x plus 9. Now multiplying this by 1 and replacing it with ln e, we're going to have this. And then that's going to be divided by ln 3. And then plus 9 over 5 ln 5x plus 9 over ln 3. So now let's convert the logarithmic expressions, the natural logs, back into the original logarithmic expressions. So ln 5x plus 9 over ln 3 is going to look like that. It's going to be log base 3 5x plus 9. And then this is going to be minus 1 over 5 5x plus 9, ln e over ln 3. This time we're going to do it right. It's log base 3 of e. And then plus 9 over 5, log base 3, 5x plus 9 plus c. So what we need to do at this point is we need to factor the log expression. So this is going to be log 3, 5x plus 9. And then in front of that, we have the coefficients x plus 9 over 5. And then minus 1 over 5, 5x plus 9, log base 3 of e. Notice that these two are the same. 1 over 5 times 5x is x. 1 over 5 times 9 is 9 over 5. So what I'm going to do here is I'm going to factor out 1 over 5. So this is going to be 1 over 5 times 5x plus 9, log base 3, 5x plus 9, and then minus what we have on the right. So now the next thing we need to do is factor out 1 over 5 times 5x plus 9. And so we're left with those two expressions. So times log base 3 of 5x plus 9 minus log base 3 of e. So now we can convert those two logarithmic expressions into a single log. So log base 3, 5x plus 9 minus log base 3 of e, we can write that as log base 3 and then 5x plus 9 divided by e plus our constant c. So this is the final answer, which is the same as what we had using the formula. So now you know how to integrate logarithmic expressions. So that's the answer to the problem. Now here's a question for you. Let's say if you have the integral of log base 7 x to the 4th power. What is the antiderivative of that expression? Well, if you ever see a problem like that on a test, here's what you can do. You need to be familiar with another property of logs. For instance, log of a raised to the 5th power is equal to 5 times log a. You can move the exponent to the front. So in this example, you want to move the 4 to the front. So this is just 4 integral log base 7 of x. So now we could use this formula. The integral of log base a of u du is going to be, it's u log base a u over e divided by u prime. So in this example, u is x, u prime is 1, a is 7. So this is just going to be 4 times u, which is x, log base 7 x over e divided by 1, which we can just write the answer as 4x log base 7 x over e, and then plus our constant of integration. So that is the answer for that problem. Now what if you had this problem, log base 2 of, let's say, x squared plus 8x plus 16. What would you do in this case? What's the answer? Feel free to pause the video and try that one. In this case, you need to realize that you have a perfect square trinomial. X squared plus 8x plus 16, you can factor that to x plus 4 times x plus 4, which means you can rewrite the problem like this. This is log base 2 x plus 4 squared. So now you can move the 2 to the front. So it's 2 times the integral of log base 2 x plus 4. And then using the formula, I should have kept it. It's u prime log a u over e divided by u prime. This should be a u, not u prime. So in this example, u is x plus 4, u prime is 1, a is equal to 2. So it's going to be 2 times u, which is x plus 4, log base 2 of x plus 4 divided by e divided by u prime, which is 1, and then plus c. So this is the final answer to the original problem. So if u is, let's say, not linear, there might be things that you can do to make it a linear function. As you saw in the last example, if we have something like x to the 9th power, you could move the 9 to the front when dealing with logs. And if you have a trinomial, if you can factor it, if it's a perfect square trinomial, then you could factor it like this and then move the exponent to the front. If you can't do one of those things, you have a hard problem on your hands.